In this example, I'm going to be showing you how to find probabilities given a table. It's really easy to get overwhelmed and not really kind of understand how to start, but this is actually pretty easy once you figure out how to get the information you need. So suppose a customer is chosen at random from the above table. Find each of the probabilities. So the first one is asking us to find the probability that the customer was male. So you will see that the rows indicate gender, so male or female, and then the columns indicate the type of treatment they received. So manicure, pedicure, or facial. So if we just want to know how many customers were male, right, what's the probability that a customer was male, we would look for male, so we'd look across. So the total number of males is 20. The total number of customers is 85. So the probability that the customer was male is 20 out of 85. And you can either try to reduce that fraction, make sure it's in lowest terms, or you can just divide. So if I divide to find a decimal, it would be 0.235. Okay, part B, find the probability that the customer wanted a facial. So let me go erase what I did up here already. Okay, so a facial, 13 people wanted a facial, right? So facials, 13 out of the total 85 customers. So again, you can just divide 13 divided by 85 and you get 0.153. Okay, the customer was a male and wanted a pedicure. So find the probability that the customer was a male and wanted a pedicure. So let's look. First of all, we have the males. Okay. Then we want to look at a pedicure. So we want to look and see where those intersect. And that's going to be the number of males that wanted a pedicure. So we can see that 3 people were male and wanted a pedicure. So that's our favorable event out of a total of 85 customers. So the probability that a customer was male and wanted a pedicure is 3 out of 85. In decimal form, that is 0.035. Okay, part D. Find the probability that the customer wanted either a manicure or a facial. So a manicure or a facial. And so since they're just talking about manicure, they're not talking about male or female. It's just how many customers wanted a manicure or how many customers wanted a facial out of the total number of customers. So manicure is 38. 13 people wanted a facial. So both of those are favorable events and they don't overlap. So we could just add those together. So that would be 51 out of 85 customers. So divide and you get 0.6. And actually it's not approximately, it is 0.6. Okay, part E. Find the probability that the customer was either female or wanted a facial. Okay, so female or facial. So in part D, manicure and facial were both columns, so they didn't overlap. But in this one, female is a row and facial is a column. So we're going to have a number, this number 8, that overlaps. So you don't want to count the 8 twice. So be really careful with that. So what I would suggest doing is ignoring the totals and adding up each individual part. So we would add up 26, 31, and 8. That includes all the females. And then we also need to add in the 5 for the facial, right? Don't add up the totals. If you just do 13 plus 65, you're going to be adding an extra 8 because that 8 is being counted twice. So just count all of the sections, right, that aren't the totals. So we'll have 26 plus 31 plus 8. That comes from females. And then the 8 is already counted for facial, plus another 5 for facial. That's going to give us our numerator. So 26 plus 31 plus 8 plus 5 is 70. Over the total is 85. So we can divide that, and we would get approximately 0.824. Okay, part F, find the probability that the customer did not want a facial. Okay, so find the probability that the customer did not want a facial. So if we've already found the probability that they did want a facial, which we did, those are complementary events. So if we know that we have a complement, we can simply subtract that from 1. So if we do 1 minus 0.153, we will get 0.847. If we didn't realize that we'd already done the complement, or if maybe we weren't asked that in a scenario, we could simply go up to the chart and find all of the people who did not want a facial. So that would be a manicure, a pedicure, so 38 plus 34, not the 13 because that is a facial. So 38 plus 34, that is 72. So 72 divided by 85 is the same thing we just got in the red. So 0.847. Okay, part G, find the probability that the customer was female given that she wanted a manicure. So this is something totally different that we haven't seen before. The given that she wanted a manicure is really important, and that's where you want to start. So given that she wanted a manicure means we're only going to be considering the people that wanted manicure. So the given is our new denominator. Okay? So the given part is the new denominator. So we're only considering people who wanted a manicure. So how many total people wanted a manicure? Well, that was 38. So 38 is now going to be our denominator. And we want to know, given that, what was the probability that it was a female? Well, there were 26 females. So 26 over 38 is going to be the fraction. We can either reduce that fraction or we can write it in decimal form, and that'll be 0.684. Part H, this is the last one. Let's move this up a little bit. Okay, part H, find the probability that the customer wanted a facial given the customer was a male. So remember that the given statement is telling you the new denominator. This is what you should consider. So new denominator. So in this case, we're only considering males. So I'm going to go and find my males. So the denominator is the total number of males. So that's 20. So my new denominator is 20. Given that they're male, how many males wanted a facial? So we're going to look for facial. So 5 of the males wanted a facial. So 5 out of 20 wanted a facial. So you can either reduce that fraction or you can just divide and you get 0.25.